Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. All math based, of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. If you step on inside, I am going to be doing a review, an overview of sorts of all my integrated math 3 information on surface area and volume of solids. There are going to be some other things here involved that I did not cover in recent videos regarding ratio of area, ratio of volume, and density. Now I'm gonna have covered some of this with my classes. Maybe I can find some sort of thing to do a solution guide video with on top of this, and if I do, maybe I can wait to publish this one as well. We'll see. But either way, at the time of me recording this, I have not yet covered things involving ratio of area, ratio of volume, and density. They all go relatively fast. It's a very simple kind of, I don't want to say formula, yeah, there's a simple formula to go by with them, and there are some problems that are going to be involved in this thing. So with this overview, guys, I have a PDF. If you find the description section down below, you will find a link to the PDF of this alongside the timestamps for each problem that I run into. Now, for my students, just a big heads up, these problems look a little difficult. I haven't done these ones before. I didn't make this review. There were actually two problems that were the same, so I had to make another one on top of it. But I haven't done this one before, but it looks a little complex as far as the workaround. So my recommendation is this. Your exam wouldn't be as hard as this, and I can imagine that for other students as well, because there are I'm looking at a lot of composite solids on these things, and just the way that you have to navigate and find the missing parts, it's really just understanding your shape. So my recommendation is this. You might be stuck on some problems. If you want to watch the video for some parts, just how to build it and get started, great. Try the rest of the problem for yourself and what you can do, and then come back to this as need be. Now, there was also no mention of what to round to or leave in terms of pi or whatever, so I just decided I'm going to have you round to the nearest hundredth, at least for the answers that I do. That doesn't mean that you round early, though, that you don't use the stuff in the calculator early. You do it at the very end, so I'll wait till the very end to do that. Speaking of which, with the calculator, I did get a class set of calculators for my class, so this kind right here, and I decided to find emulation that mimics this. So you're going to be looking at now instead a calculator that looks like that with what I do, so it helps my students in case this is the kind of calculator that they use. This is what I recommended them, TI-30XS Multiview. Now I haven't done this calculator yet here, so I wonder if there are any settings I have to change. We'll figure it out. It's like getting a brand new calculator. All right, guys, without further ado, I'm going to go ahead and get started on this thing. Let's take a look at what all of this looks like. Starting with the first problems on number 1, rounding to nearest hundredth, find the volume of each figure. Now, part A, we have an oblique cylinder next to a cube. And here's the information, what it looks like. The distance from this part to this part right here, from top to bottom, is 24 feet in its entirety, in length. We have, and that's perpendicular distance, right? That is height. When you have an oblique cylinder like that, we need that height, right? Perpendicular distance between your bases. So we got to find that out. And because this is a cube, we know that every edge is congruent to one another. All these things are congruent. So information-wise, we have the full 24, and we know that the radius of this circle here, the circle base, is 10. Now this one's kind of interesting as you look at it and say, how do we work out this problem? What are the dimensions of the cube? What's the height? How do we work that out? Well, what I do see here is that this circle right here, which it I guess is not totally drawn to scale, but the circle does touch the top and the bottom right here. So that means that the diameter of this thing also represents any of the base edge lengths of the cube, such as this would be congruent to this right here. So if this is 10 as a radius, then the diameter here, the entire diameter, is 20 feet. That means that this cube is 20 feet here and 20 feet all the way around. Everything here on the cube is 20 feet. Just because you have this distance is 20, and that's going to mimic that, and then everything in a cube is the same. So 20 by 20 by 20 when it comes to the cube, that'll help us for its volume. Now, how does that help us find the height? The height of this oblique cylinder? Well, the height is a combination of this height of the oblique cylinder here, I'll call h, and then the rest of this height here, which we just found out was 20. So if this is 20 feet going across here, then the rest of it makes, it makes the rest of the height there, which would, then be 20. So, the whole thing's 24. Then this is 20, or 24 minus 20, which would make this is clearly not drawn to scale, guys. This would be 4 feet, a 4-foot height for this figure. I'm going to call this figure 1. I'm going to call this figure 2 right there. So the height of my figure 1 of my oblique cylinder is 4 feet. The radius is 10 feet. We need both of those things for the volume of any cylinder. The volume of a cylinder is area of base times height, pi r squared times height, even the oblique ones, as long as we find the perpendicular distance, and we found that thing. So the volume of the oblique cylinder here is area of base, pi r squared, times the height of 4. So that's going to be 400 pi square feet, cubic feet, I should say. 400 pi cubic feet. That's the volume of the first guy. Now I'm going to add this with the volume of the cube as well, and I'll go ahead and I'll round at the end of this thing. So for object 2 here, the volume is area of base times height, 20 times 20 times height. So really 20 cubed if you think about it that way. 20 times 20 times 20, that gives you, I think, 8,000 cubic feet. So the volume of both of these together, the volume of the total, I'm going to add those. I get 8,000 plus 400 pi. Now this is not 8,400 pi because pi only exists with the 400. Instead, I'm just going to use the calculator for this part. And then I'll just put cubic feet there. And I'll round it. I'll round to the nearest hundredth and use the calculator. Do 8,000 plus 400 pi straight up. So I'll go to the calculator for this one with you guys here. I don't know how many times I'll go straight to this, but I just want to let you know that it's there. Now if I type 8,000 plus 400 pi right here, this is kind of slow. There we go. I'm going to get 9256.64. If I round it up, 0.64 cubic feet. So let me first write it. Actually, you guys can watch it. 9256.64 cubic feet. There you are. Okay, so anyway, that's I didn't round early. I could have arguably rounded early on that one because this one was an integer and there was no multiplication, but it's just better not to when you don't need to, or especially if you need to answer something in terms of pi. Make sure you know how to. All right, that is 1A. 1B. On 1B, here we have a cone and a cylinder down below, and we are finding the volume of both of them together, of this composite solid, if you will. So a cone here, that volume is 1/3. Let's call this 1, object 1, object 2. Volume 1 is 1/3 area of base times height. 1/3 area of base times height. And then the volume of this guy here of the cylinder is area of base times height, the pi r squared times height. Now this base, let's crack what this base is. Let me use a different color actually for this one. Not a lot of room on here, I'm very sorry. The base here, let's use that purple, maybe a different purple. A different purple. All right, the base here, pi r squared, right? Pi r squared. I have a radius of 5 centimeters. I want to make sure my face, there we go. Pi times 5 squared is 25 square centimeters. Oh, 25 pi square centimeters there. The height of object 1, the height of the cone, I still have to find using Pythagorean theorem here because this is going to be going down the center. That's the h I need to find. And we know that this radius is 5 centimeters no matter what. We got a slant height of 13 centimeters right there. So what we're looking for there, we have 5 squared plus h squared equals 13 squared. So 25 plus h squared is 169. Going to do the math kind of for you quickly. H squared is 144, so h is 12. You get 12 centimeters for the height, and you have an area of a base of 25 pi. So, didn't mean to do a circle there. Sorry about that. So, the volume of object 1 there being 1/3 area of base times height. We're going to be doing 1/3. Area of base was 25 pi, and the height is 12. As an exact answer for now, I'm going to get 1/3 of 12 is 4. 4 times 25 pi is 100 pi. That's 100 pi cubic centimeters. That's the volume of the cone up top. The volume of the cylinder down below should arguably be easier with the one bit here. The whole thing, I didn't even look at this. The whole thing is 30 centimeters in height. So with this being 12 right there, the rest of it, this is just like the other problem. The rest of it, if this is 12, the rest of it's 18. So that's 18 centimeters of height of your second object. 18 centimeters. Really not a lot of room on this one. My apologies. Maybe do this on binder paper. So volume 2 here is area of base, 25 pi, still the same circle, right? Times a height of 18. 25 times 18, 450? I think so. 450 pi. So volume 2 is 450 pi cubic centimeters. I hope that's right. Anyway, so volume of the total there is going to be 100 pi plus 450 pi, which is 550 pi cubic centimeters. That's an exact answer. Yeah, boy, I really wish I had some more room on this one as I was working on it. So approximately 551 is probably 1700 or something like that. Let's go to the calculator there. Nope, that's 550. Kind of slow. Oh, I hit the on button. 550 pi. Did I hit enter? Whew, slow emulation. Uh-oh. This thing might have crashed on me. Did I hit the enter button? Oh, you know what it's doing? Oh, I'm sorry. Okay, so here's an example. This is what's called, it's in math print right now. So I got to change. I went to mode. Let's go to classic mode and quit out of that. It is a little slow, though. It's a little chuggy. How do I recall previous answer? I'll just type it again. 550 pi. I'm working with the calculator, a little new as you are. All right, 1727.88 as I round up. 1727.88 cubic centimeters, and that is the volume of the second object. So a little tricky to start off with, right? We already got two composite solids where we had to kind of deduce information. I'd say the first one was harder, but we had to deduce information based on a complete total. I'll tell you right now, man, I don't expect too much of this kind of stuff on your test, with the exception of parts that we've already played with in the past. And I'd say this one is good to play with here, even though nothing's totally completely drawn to scale. I hope that's okay. All right, part C, number 1C, a cone removed from the prism. So cone, same height as prism. So I'm guessing here the cone is on the circular base is on top there, and then it's cutting into there. So this height, they said, is the same height as the prism. So 25 centimeters for the height of the cone as well. So the overall heights we're looking at here, guys, is 25 centimeters, no matter kind of which way we're looking at it. And then the cone is a diameter of 10 centimeters there. So its radius, I'm going to call that, I'm start with object 1, but the radius is going to be half of that, okay? All right, so let's start with some object 1 material here. We can get, it's just volume, right? So we can get volume straight up, area of base times height. So volume of object 1 is area of base times height, which is going to be an area of base 1 is going to be 7 times 6. You could do it all as 1, 7 times 6 times 25, but this is just to break things down this way. It's 42. The height is, once again, 25. We already have that. Square centimeters. So the volume is going to be area of base 42 times height of 25, which is 1050 cubic centimeters. So there's the volume of object 1, the rectangular prism. Object 2, I'm going to call the cone there. So volume 2 is going to be, one more time, 1/3 area of base times height. This is a different kind of area of base now. Area of base is going to be pi r squared within here. We do have the height as 25 though. So the radius for this guy, this is going to be 10 over 2, which is 5 centimeters. So the area of base 2 is pi times 5 squared, which is 25 pi. I think we saw that before, square centimeters. So the volume of 2 is 1/3 area of base, 25 pi, times a height of 25. There's no exact, it's a fraction. This is 625 pi over 3 cubic centimeters. And I'm going to leave it like that for now. I'm going to leave it like that for now before I don't want to round it. I could, because this is just an integer here. But the volume of the total, I'm going to add those two up. I'm just going to go ahead. I'm going to use the calculator straight up for it. But volume 1, I'm just going to put volume 1 plus volume 2. So I'm going to do 1050 plus 625 pi over 3. Just, at that point, we're going to kind of get some rounding in. So here we go. We got 1050 plus 625 pi. Hope I'm not miscalculating some of those things in my head. I don't think I am. Over 3. We got 1704.498. That rounds up to 0.50. So that'll be 1704.50. Everything's rounding up so far. 1704.50 cubic centimeters. I don't even have any room for 4. Thank goodness it's not a composite solid. At least it doesn't look like it. No, it's not. All right, so that is part C there, not number 4, part C. Part D right here. Let's find the volume of this. It's a triangular pyramid, and it's got a right angle. It's got a right triangle base there with I can call base and height 6 and 7. Right? You need perpendicular lengths in order to do the 1/2 base times height of this thing here. So as I'm pulling, and it looks like the height of this thing is 18. I'm going to consider that the altitudinal height. That's just, that's the height from the base to the apex there. So the area of the base right here is 1/2 base times height, 6 times 7. Half of 42 is 21. And that's, again, centimeters, so square centimeters. And your height is 18 centimeters. So your volume is 1/3 area of base times height. No pi. No pi. The third of, let's do a third of 18. That'll be easier. Third of 18 is 6. 6 times 21 is 126. So 126 cubic centimeters. Good, I didn't need a lot of room for that. All right, part D was kind of the easiest one with that. There we go, that's nice. All right, so those are some volume questions there. They were kind of difficult with respect to what you had to do. It's kind of a breakdown in understanding, but once you have the parts, you're using the formulas that you have to get the volumes. Pardon the big mess there, okay? Pardon the big mess. All right, now we're going to find surface areas. Number 2, find the surface area of each composite figure. You have a cube connected to a right cylinder, so just an upright. It's not oblique, it's just straight up and down. And then we do have a cube. So it looks like there's some breakdown stuff again. 24 is the entire distance between these. They did call this a cube. That means if this is 10, the rest of these are 10, such as this drawing is a little defunct there, that's okay. But such as that being 10. If all this is 10 here and the whole thing is 24, that makes this height 24 minus 10. That's 14 feet. Hope that makes sense. 14 plus 10 there gives you the whole 24. So that'll help for that. And just remember, when it comes to these for surface area, y'all, you got that circular base that is not a part of your surface. It's not only not a part of the surface of the cylinder, but it is also covering that amount of surface in this cube. So when I find the surface area of the cube, I need to subtract this circle away because that part's covered. And then if I find the whole surface area of the cylinder, I'm going to subtract that as well. So I might as well subtract it twice. What I've sometimes told my students to do in some of these is just find the lateral area plus one of the base areas, and you can totally do that. But since I'm already subtracting it once, I'll just subtract it twice. I hope you don't mind that. So I'm going to find the surface area of both of these all together, take away that circle area twice, and that should be our surface area of the composite figure. So I'm going to call this one object 1 and this one object 2. Objects 1 and 2. So let's find the surface area of object 1. That's going to be the lateral area plus the area of both of your bases. Now the lateral area in this case for this object, we have to get the circumference of your base, 2 pi r, times the height of the cylinder. So 2 pi r times h, 2 pi r h. So 2 pi times the radius, which is 4 centimeters, that'll get you circumference, times the height of this entire thing, that's going to be 14, like that. And then 4 times 14 is 56, times 2 is 112. So you get 112 pi square centimeters there for the lateral area. The base area is just pi r squared, so pi times 4 squared there, which is 16 pi. Now, yes, it is kind of irrelevant to add both of the pi's in, I know, but just to kind of have it all-encompassing, I know that if I get the whole surface area and that whole surface area, I know what I'm going to subtract. So the surface area of the entire cylinder here is going to be my lateral area 112 pi plus both of my base areas, whoops, just 16, just a single 16, pi, which is 112 pi plus 32 pi, which is 144 pi. Yeah, it's 144 pi square centimeters. Now I'm going to leave it like that and leave it exact for now. That's surface area of figure 1. Figure 2, right here, it's a cube. It's not length times width times height though, right? We got to do LA plus 2B, same kind of thing here. So the surface area of figure 2, also LA plus 2B, but because it's it's a cube, but because it's a square prism, you have a square base, and then you have the lateral area, which we got to get as perimeter base times height. So the lateral area of figure 2 is perimeter of base times height. It's 10 all the way around. It's 4 tens, 10 plus 10 plus 10 plus 10, or 10 times 4, times the height, which is also 10. So 40 times 10 is 400. 400 square centimeters is the lateral area. If you considered this, the right, and the back, those 4 all the way around, if you consider those the lateral area. You can consider this maybe base and base. Either, it doesn't matter as it's rectangular, they're squares. Just make sure you follow along with what you did. The base for this thing is going to be 10 squared, 10 times 10, which is 100. So the total surface area is LA plus 2B, your 400 plus 2 100s, which is 600 square centimeters. So the surface area of the total here, I'm going to add these two. I'm going to add 600 with 144 pi. But then I got to take out that circular area as it's covering that part of the surface area of the cube, and it is part of the base of the cylinder that is covered and no longer surface. So I got to subtract the circle area twice. So my surface area of my total will be my surface area 1 plus surface area 2 minus 2 of these 16 pi's, really 32 pi, minus the 2 16 pi's there. If you want an exact answer, that that the 32 pi, I guess I'm subtracting the 32 pi again, right? I'm getting back to 112 pi. So 112 pi, and if someone recognizes that, of course they can do that for the problem. Plus 600, that is square centimeters. So there's an exact answer. As an approximated answer, probably getting close to 1,000. Still under, I think, but probably getting close to 1,000 there. Let's go to the graphing calculator, or the calculator, I should say. And we're going to get 112 pi. Did I hit 12? Nope. Pi plus, it is a little laggy, 600. So much that emulation can do, I suppose. 951.86, rounding up again. So 951.86 square centimeters for that one. Always leaving units for these, and because it's area, it's square units. Yeah, definitely not a lot of room here, but there's only one more for part B, and then I have all this room for number 3, however much room I'd love to give. But there it is. There we have it. All right, part B, a lot of the same old same old. We got a rectangular, we have a rectangular prism. We have half of a cylinder right here, and as you can tell, there's a rectangle there that's covered. A little tricky with that. So in terms of playing this thing out, well, you know what? It's covered, so that's not too bad. There are a lot of ways you can strategize this to make it easy for you. For example, consider this back circle right there. If I put that back circle down right here, not like covering it, but I make a full circle like that, so I don't necessarily need to find the area of 2 half circles and put them together. I'll just find the area of that circle, that one circle, and that's considered both the front and the back. And then I'll just take half the lateral area, and then that little rectangle on top is just covered, right? I don't even need that part of the surface area. It's covered, and it's covered on the prism as well. So if I have figure 1, let's do a different color. If I had figure 1 and figure 2 right here, I'm going to find these in kind of a more strategic way this time, because I know that this part's already covered. It's covering exactly both the top and bottom in an exact amount. I just won't include it at all. So on figure 2, let's do figure 2 first. I think it's going to be easier. I am going to find the lateral area, and I'm just going to find the area of one base and add those together. And I'm going to consider that my surface area of those things as far as uncovered aspects. So my surface area for my 2, not as an actual formula for rectangular prisms, but just for this, it is the lateral area plus the single base that's on bottom. Remember, the top one is covered by the half cylinder. So I'm just going to take those 2 things only. All right. The lateral area for the second one, I am going to still do perimeter of base times height. My perimeter looks like I'm going to be doing 7 plus 13 plus 7 plus 13, right? 7 plus 13 is 20, plus another plus 7, 13 is another 20, that's 40, times the height of my prism is 8. What did I say, 40? 40 times 8 is 320. So 320 square millimeters for my lateral area of my rectangular prism. The area of that single base, that's 7 times 13, that's what we're doing right there. 7 times 12 is 84, so 91. So 91 square millimeters there. So my surface area of the uncovered stuff on 2, the only parts that I'm really considering there, and I don't know if I really should be putting that because I know it's LA plus 2B. But anyway, so that's going to be 320 plus 91, which is, what's the 411? Which is 411 square millimeters. So that's the surface area of the uncovered portions of the rectangular prism. The cylinder, I am, again, there's a back half circle and a front half circle. Together they make a full circle. So I'm just going to find the area of that circle using pi r squared. We need its radius. You can tell nothing's marked up here, but if you consider this 7, that also represents up here, which would be the diameter of what would have been a circle up there. So the radius is half of that, right? The radius of that object is 7 over 2, exactly 3.5. I can go ahead and do that for you, 3.5 millimeters. I sometimes like to keep the fraction, but you know, it's whatever. So the this whole surface area of this top, I'm going to I'll still call this the base, the full circle there. So the base of this thing here, we got to find that. That's just going to be my pi r squared. Remember, there's a half circle on the front and on the back. So pi r squared. I think 3.5 squared is 12.25, so I have 12.25 pi square millimeters for the area of the base. Now my lateral area for this thing here, normally it's circumference, perimeter base times height. Height being, by the way, the 13. And perimeter base meaning the circumference of the whole thing. But in this case, circumference is half of it. I don't care that there are 2 half circles. Circumference, we're only taking half of this thing. So instead of 2 pi r, let's take half of 2 pi r. Half of 2 pi r is pi r, right? 1/2 of 2 is 1 in pi r. So this is going to be pi r. Instead of 2 pi r h, it's half of that. It's pi r h. Pi times the radius times the height. Okay, now I kind of want to use a calculator. And I'll get the exact number in terms of pi first. So 13, it should be 45.5. Yeah, 45.5. So that's 45.5 pi square millimeters there. So I didn't really write it as a surface area, the whole thing here. Let's see if I can get that all fit right in there. So the surface area, and I know I'm blocking some objects here. Let me go ahead and move my face there. All right, the surface area of that 2, the uncovered portion is going to be that half lateral area that we have right here of that guy. That is my 45.5 pi plus the area of this half circle. Area of this half circle is going to be the 12.25 pi. 12.25 pi, which is exactly 57.75 pi square millimeters. All right, so we have the surface area, the uncovered surface area of figure 1 on the top. We have the uncovered surface area of figure 2 on the bottom. Not the true ways that you would get surface areas of these, but that's okay. So the surface area of the total, we'll just be adding those two together. Nothing to subtract because I only considered uncovered portions. So that's going to be 411 plus 57.75 pi square millimeters. And when I go ahead and use the calculator to round that guy for you, we'll get close to what, 675 or so? Let's see. 411 plus 57.75 pi. Oh, I don't know what I said as an answer. I might have been wrong. Anyway, 592.43. Once again, rounding up. 592.43 square millimeters there. Another composite figure down. All right. Little OCD. I have some equal signs there that I don't want. All right. Non-composite figure here. We are trying to find, I guess, the surface area. It just says number 3, so I don't know if that's supposed to be a part C. The last thing that was asked for was surface area, so I'm guessing this one's surface area. You know, I'll find both. I'll find volume and surface area. Volume's going to be really fast. It says a vertical height's 8, right? That's the altitudinal height right there, and that's the one that you need for volume. So in case I need to find both, let's go ahead and do that. So the volume is going to be of a pyramid, 1/3 area of base times height. It is a regular pyramid. That means the base has all equal angles, equal, hang on, let me move my face here again. Equal angles, equal lengths there. It's a square. It's a square. So the area of the base there, and I need area base for surface area anyway. So that's 12 squared, which is 144. And of course the height, not the slant height, but the altitudinal height being 8, means the volume is 1/3 area of base, times height. A third of 144, gee, that's 48. I think. 48. 48 times 8. I should know that. 48 times 8 is 384, I think. So 384 cubic centimeters there. Let me triple check that, even my division there, 144, because I'm doing all this kind of in my head. Divide by 3 times 8. Yeah, 384. So 384 cubic centimeters for the volume. I don't know if that's what was asked for, but I got you volume. All right, surface area. I did want to put my height inside here because surface area requires slant height. And for slant height, I need to kind of find this guy right here, my L, which in essence would be the hypotenuse in a right triangle here, where we can use Pythagorean theorem to now solve. And we need to find out this length right here. But in a regular, base right here, if this is 12, this would be half of it, which is 6 centimeters. I can tell you right now this is going to be 10. Kind of sweet. All right, so the L, so 6 squared plus 8 squared equals L squared. 36 plus 64 is L squared. L squared is 100. L equals 10. So we have 10 centimeters slant height, and we need slant height because to find the surface area of this guy, the lateral area is 1/2 perimeter of base times slant height. So the surface area in general is lateral area plus the area of your base, of your pyramid there. The area of the base we do know is 144 square centimeters. I'm going to leave that. The lateral area is 1/2 perimeter of base times slant height. Perimeter of base is all 4 12s added together. 12 plus 12 plus 12 plus 12. Let me just write 12 times 4. I hope that's kind of okay. Slant height we just found out was 10. Okay, so half of all that, right? 12 times 4 is 48. 48 times 10 is 480. Half of 480 is 240. So 240 square centimeters is the lateral area of the pyramid. When we add that with the area of the base of 144, we'll get the entire surface area. So 240 plus 144. Hey, that's 384. Isn't that fun? No matter what you calculated, you get 384. This is the first time I did the problem. So no matter what, you get 384. Now, the 1 square centimeter, 1 cubic centimeters, they don't mean the same thing. I'm just saying it's cool that you get the same number. Ta-da. All right, some composite solid stuff, some fun stuff. Gosh, that was a lot that I did here. And over a half hour's worth of it. All right, good study material though, yeah? All right, let's keep moving on here. One more page. I know this is only a 2-page thing. Use the solids below to answer the question. So I kind of have 3 parts here. What is the volume, surface area of the objects? And if the radius is tripled, what would be the new volume and surface area? So that's the kind of ratio of things I was talking about. Let's start with the first 2. What's the volume of the object? This is a sphere. The volume is going to be 4/3 pi r cubed. And our r here is 9 centimeters. So when we find the volume here, our volume is going to be 4/3 pi times 9 cubed. I don't know if I can do all this without a calculator here, but 9 cubed is 729. A third of 729 is 243. And 243 times 4, if any of the math teachers are watching this, I'm sorry. 900, oh man. 972. I'm going to try that. 4/3, sorry, you're not looking at this, times 9 cubed. 972. Okay, so 972 pi cubic centimeters. Now I'm going to go ahead and round that because I said I'm going to round everything. Just because. So times pi. I'm getting 3053.628. So 3053.63. Everything's been rounded up so far. I hope you know how to round. So there's the volume of that sphere. I don't know if that's a big, I guess it's not a big sphere. It's kind of like a baseball. All right, that's how many, all right. The surface area, so that's A. The surface area, part B, or the second part, that's going to be 4 pi r squared. It'd be a lot easier even for me to calculate. So surface area, 4 pi times 9 squared. 9 squared is 81. 81 times 4 is 324. So this becomes 324 pi square centimeters. And then I'm going to go ahead and jump to the calculator for the rest. 324. Hopefully you're okay with, again, me not showing you the calculator. Just gotta type 324 pi. 1017.87. Isn't that exactly a third of this? That is. That's exactly a... Yeah, that's exactly a third of this. Interesting. These are... I don't know if these were thought of when we did the problem, when the problems were made, but it's cool. The surface area is exactly a third of the volume. Is that always true? Did I know that? No. Anyway, so 1017.88, it rounds up, 0.88 square centimeters. If you'd like to look at it here for 1 second, this is what I've done. What did you do? 1017.88 square centimeters. That's those two. All right, kind of running out of room for the last question here, so I'll kind of do it up top. If the radius in tripled, I assume the mean is tripled. If the radius is tripled, what would be the new volume and new surface area? Okay, so the thing that I want to point out here is if the radius is tripled, right? So if the original radius is 9, then the radius, I don't know, 3 times, the tripled radius is 27, right? It's 3 times larger. So the ratio, the similarity ratio that I call it, I put an RS here. The similarity ratio from the original to the new one there is 9 to 27, right? That's 1/3. Everything was tripled there. So one's 1/3 the other. I don't know, the original to the new. That doesn't really matter as long as I keep things intact. So anyway, so the similarity ratio is 1/3. Now, here's what happens. If you want to get an area ratio, if I want to find what the new surface area is of this, without needing to actually calculate anything else, all I do is I take my similarity ratio and I square it. My area ratio is my similarity ratio squared. So I'm going to take 1/3 and square that. 1/3 squared, 1/3 times 1/3, you get 1/9. Now this is the proportionality that I'm going to have for my original surface area to my new surface area. So my new surface area here for this guy, what I'm going to get, my surface area for the 3 times larger lengths in object is going to be found, let's see, hang on, I'm gonna go ahead and call it X, if that's okay. I'm just gonna go ahead and call this one X. I go 1 to 9 with that ratio there, that whatever my original surface area ratio was, 324 pi, I'm gonna go ahead and make it basically 9 times larger. 9 times larger. That's the proportion that I set up. 1/9 is 324 pi over X. Cross multiply, whatever you call it, X times 1 is X. 9 times 324 pi, that's the goal. Make it 9 times larger. 324 times 9 gives me 2916. So I get 2916 pi, which rounds to times pi 9160.88. This one actually doesn't round up. 9160.88 square centimeters. And I'll be honest, I think it would have been faster if I took 4 pi times 27, squared on that particular problem. But if you do that, if you do 4 pi times 27 squared, you're going to get the same answer. Because 27 centimeters was the new amount there, right? I think that one would have been faster for that problem. Some other problems it wouldn't be, because it's not just one variable. You'd have to do it for a bunch of other parts, and you're not just cubing it. But I'm just making sure that you have a connection to what you do for that particular problem, and in that instance. And that's what you do. You take it for a ratio, area ratio, you go ahead and you square the similarity ratio there. Volume ratio. Let's see if I can fit it here. I want to drag these things up. The volume ratio. Use green and blue. Let's use kind of a darker blue. Volume ratio, I'll call that Y when we do that. But the volume ratio, you take the similarity ratio and you cube it. So if I take my 1 to 3 original thing, where 1 is the original, 3 is the larger, and I cube it, I'm going to get 1/27. So my volume should be, essentially, without even needing to write a proportion, your volume is going to be 27 times larger in your new object than your original volume. It's going to be 27 times larger. So you could do 4/3 pi times 27 cubed, and you'd get your answer. But as far as setting this one up, I could do, once again, another proportion. 1:27 as the original volume of 972 pi is to my new volume there, y. And if I cross multiply there, I get y equals, and I have 27 times 972 pi. So 27 times 972, oh, I did 27 times 97. 27 times, this thing kind of lags, 972 is, I get, whoa, that's a big number, 26244, so pi, that's in cubic centimeters, and rounded, when I multiply by pi, rounded to the nearest tenth, 82447.96. Again, sorry that I'm not showing the calculator anymore. 82447.96 cubic centimeters there. Yeah, it's very clustered. I should just use this calculator as long as I'm not showing you. But that's the answer to that guy there. Again, not very much room as I work all this stuff around. Really, really big old my bad on that. All right. Part B, same questions. Let's see if I can give myself that room on this one. Arguably, this one might actually take longer to do because this part's not as fast. So let me start with the volume. What is the volume of the object? And in order to get this thing, guys, I have to go ahead and use Pythagorean theorem to find the altitudinal height right here, because we're only given the slant height, and you need this height for it. And it looks like this is not going to be one of those clean numbers. This is a square bottom, a square base here, 888 all around, so this is going right down at the center. This is cutting it at 4 centimeters there, and you have the 15 as the hypotenuse. It's the slant height, but it's the hypotenuse of the right triangle there. So I have h squared plus 4 squared equals 15 squared, like that. And h squared, oops, h squared plus 16 equals 225. So h squared is 209. So h is the square root of 209. It's always centimeters, isn't it? 209 centimeters there. It's somewhere between 14 and 15, a little more than 14 and a half, I mean, around 14 and a half, I imagine. But I'm not rounding it early, right? I'm going to leave the square root of 209 as long as I need it. And honestly, I only need it once when I calculate the volume. I don't need it for surface area, and I don't need it for ratio, for the volume of this new dimensions thing. So I'm just going to use the ratio idea for it. So the volume of this thing as 1/3, area of base, by the way. Area of base is 8 squared, which is 64 square centimeters. So the volume is 1/3 area of base, square root of 64, times the height, square root of 209. I'm just going to go ahead and round this one now. I'm going to go and use a calculator. I don't need 1/3 of 64, and I have the root 209 there. So let's do 64 divided by 3 times, I'm watching the calculator here. 64 divided by 3, that's 1/3 of it, times the square root of 209 right there. And I'm getting 308.41. So 308.41 cubic centimeters there. All right, there you go. The surface area. Surface area, we have the slant height as 15. We need the perimeter of the base, right? The lateral area is 1/2 perimeter of base. That's 8 times 4. That's 32. Perimeter base times the slant height there of 15. So the lateral area is going to be, I was about to take 1/3. So 16 times 15, which is 240. 240 square centimeters. Of course, the area of the base is 64. So the surface area is going to be 240 plus 64, which is 304 square centimeters. Pretty close to each other at that time as we got those. But again, they mean different things. Okay, next question here is, if the dimensions are all cut in half, what would be the new surface area and volume? So if the dimensions are cut in half, again, I'm not going to remeasure everything, call that 4 and 4. You can, but then you got to recalculate everything. You even got to cut 15 in half, make it 7.5, do Pythagorean theorem again. It's not very fun. This is a problem where using the volume ratio and the area ratio is really of great concern, of great fortitude for you. And honestly, I probably should have done new over original, called it 3, so you understand the 3 times part a little bit larger. I feel bad for not doing that now. But here I'm going to actually say 1/2. So if the similarity ratio here is 1/2, meaning this time new over original, I guess, if you will. The similarity ratio is 1/2. Basically, just know that our original one's the bigger one, and we got to find the smaller. Okay. The ratio of areas, we got to take 1/2 and square it. 1/2 times 1/2 is 1/4. Okay. So I'm going to go ahead and I'm going to set this one up. Basically, you're taking 1/4 of this. You're taking 1/4 of the surface area. If you're okay with that without setting up a proportion, understanding you're going to divide it by 4. That's okay. So 1/4 of 304. I guess I should know it. It's I don't know. 75.76. 76. 304 divided by 4. Yeah, 76. So 76 square centimeters there for the new surface area. God, really apologize for the room. New volume. The volume ratio, you take the 1/2 and we cube it, and we get 1/8. So everything's going to be 1/8 the size. So I'm going to take I'll take my exact one. I'll take this exact one here, and I'll divide that by 8. So I'm going to take 1/8 of this. Now, if I take 1/8 of this, I can take 1/8 of the 64 and call that 8, right? So my new volume here, I'll call it volume new. My volume new here is going to be 1/3 of 8 times root 209. I just applied the 1/8 to the 64. I don't know if that makes sense, but I'm doing 1/8 times 1/3 times 64, root 209. All right, so back to the calculator here. Back we go. 1/3, so 8 divided by 3 times the square root of 209. Yeah, I don't want to use my rounded answer for this. I want to go ahead and use the calculations as there. So 38.55 there. So 38.55 cubic centimeters. All right, really tricky stuff, and again, not a lot of room for it, but there they are. If you know your ratios off the crack of the bat, like that, you could just do a quick division. You can just do a quick division when you're coming up with it. Okay, 3 more questions in total. Number 5, a concrete cone with a mass of 93 pounds is shown below. What is its density? All right, these questions say density here, here, and here. So these are all density-based questions. That doesn't mean we don't still calculate things, because density of an object can be calculated as its mass divided by its volume. We have the mass of 93 pounds, so M is 93. We need the volume, and then we'll have density, and we'll have it in pounds per cubic inch for this thing. So let's still find the volume of this. The diameter of this is 24 inches. That means the radius is going to be half of that, which is 12 inches. So we got a radius of 12 inches in length, and your volume of this, it is 1/3 area of base times height. So we need the area of base is pi r squared, which is 144 pi square inches. And your height is 36 inches. So your volume of your cone is 1/3 area of base times height. I know 1/3 of 36 is 12. I don't know 12 times 144. I don't know it. One of the ones I probably should have memorized. 140, because it's 12 cubed. I don't know 12 cubed. 1728. So 1728 pi. Now I'm going to leave it like this for a moment. Because I want to go ahead and do the division, and then I'm going to give it, I'll go and round the density to the nearest tenth, unless those things can reduce. Even if they could, I don't know. I'll give you the exact answer in reduced format as well. Let me first kind of calculate it. Let me show you what I'm going to do in the calculator here. I'm going to do 93. These should be able to reduce a little bit. I don't know if they reduce to a unit rate, though. So I'm going to be doing mass over volume, 93 over 1728. I know there's a pi, but I want to first convert this from fraction. No, I want to leave it as a fraction here. Whoa, I just hit the wrong button. I'm sorry. Let's do that again. Let's probably not worth what I'm doing here. 93 over 1728. Let's see if that can convert to a fraction. 31 over 576. I'll leave it as the decimal equivalent. So here's our number, guys. Oh, no, I need 93 over 1728 pi. 93 over 1728 pi. Now with this one, you got to be careful when you put pi. You got to put this in parentheses because this has to multiply these two things together first before that division occurs. So I'm going to do more than round to the nearest hundredth there. I'm going to round to the nearest thousandth just to give another significant value for this. So 0.017 is what I'm going to officially write there. So let's kind of go back to the mass over volume thing. Density is mass over volume. So 93 pounds over 1728 pi cubic inches is rounding to approximately, what was my number here? 0.017. I'm rounding to the nearest thousandth there. 0.017 pounds per cubic inch. Okay, that's how that density works there. In pounds per cubic inch. Mass over volume. Mass over volume, that is the density. Not very dense. Because it's very volumetric. All right, number 6. The mass of the object shown below is 30 grams. What is its density? We have two hemispheres with a cylinder in between. The cylinder looks like it has a height of 8 centimeters, and it looks like we got a radius of 2 centimeters. Now remember, that radius applies to both the two hemispheres that make a full sphere, right? They both make a full sphere together, so I'm just going to go ahead and find the volume of a single sphere with that. And then the volume of the cylinder, it has the same, area of base. It has the same radius there. So as far as objects go, let's call this volume 1, or object 1, and the middle guy object 2. So in object 1, we have a radius of 2, so your volume of the entire thing, both hemispheres together making a full sphere, is going to be 4/3 pi r cubed. 4/3 pi r cubed. 2 cubed is 8. 8 times 4 is 32. So I get 32 pi over 3 cubic centimeters right there. All right, that's volume of object 1. Volume of object 2, we got to do area of base times height. So pi r squared times the height of the cylinder, distance between your bases, is 8 centimeters. So 2 squared is 4. 4 times 8 is 32. So we get 32 pi cubic centimeters there. And total, the volume of the total thing, 32 pi over 3 plus 32 pi. If I multiply top and bottom by 3, I'm going to kind of get an exact answer first here. It's 96, so 96 pi over 3. Okay, so that total is going to be 128 pi over 3 cubic centimeters. All right, I want that exact answer when I do mass over volume, right? I got to do that mass, that 30, over this volume here, and I know the volume has a fraction within. There are a lot of ways that I could kind of clean that up. This isn't something that I'm probably practicing with my class right now, so to speak, but that density being mass over volume, the mass was 30 grams, so I'm doing 30 over 128 thirds pi, 128 pi over 3, like that. If you divide by a denominator, that could technically multiply on top. If I really wanted to get a cleaned up version of an exact answer, I could take the 3 and multiply it with 30. I'd get 90 over 128 pi. And honestly, that's probably easier to type in the calculator as well. That's cubic centimeters. This also could reduce if I wanted to play the reduction game on that. I couldn't get a unit rate or anything out of this, but I could reduce that fraction. Let's go to the calculator again. I'm going to go ahead and see what kinds of things that this reduces to. Excuse me. So, let me first type the original one in case you didn't know what was going to happen there. I'm going to do 30 over. So, I got 128 pi divided by 3. Now, that's going in all inside the denominator right there. So, I'm going to just wrap that whole thing around parentheses. It should multiply by pi first, then divide by 3 second, and then do 30 divided by that whole thing. That should give me the answer I'm looking for. So, I'm going to round to the nearest thousandth again, just because I did it last time. I'm going to call it 0.224. So density is going to be 0.224. This is grams per cubic centimeter. Is grams, someone else is going to have to tell me this. I don't remember. Is grams per cubic centimeter the same as a mole? I'm going to look that up right now. 1 mole grams per mole I can't remember. I forgot what that was in chemistry when it came to moles and things like that. Maybe it was grams per mole is something. I can't remember, unfortunately. I haven't taken chemistry in about 17, 18 years now. All right. Okay, anyway, so there's that answer there. There's the density of that. It's mass over volume once again, and getting that volume, adding those things up, we get that. And again, I'm getting an exact answer while I can. Makes things a little easier for me. All right, last question here. Number 7. About 50 wolves are estimated to live in an approximately circular area, which perimeter, probably whose perimeter, which has a perimeter of 30 miles. What is the population density of the wolves? So this time when we're referring to density, it's population divided by land area. So now this time we're referring to, here's some land. When they say approximately circular, pretend it's circular there. I know it doesn't look like a circle. It's like a flat, and then you have a wolf, a wolf, a wolf, a wolf. We have 50 wolves here. So we're going to divide. We have 50 wolves. That's our population. So density equals population over land area. That's another way of having density. It's mass over volume and population over land area. So our population is 50 wolves, right? You're basically finding out how many wolves per, I guess, square mile in this case for area. How many wolves per square mile? That shows how densely packed it is with wolves, if that makes sense. Kind of looks like a cookie. So there's the wolves. What is the land area? We have a perimeter of 30 miles. In a circle, that means the circumference. The circumference of this thing is 50 miles. And a circumference is 2 pi r, 2 pi times the radius. I need to find out the radius here. I need to find out the radius in order to... Okay, my undo button's not working anymore. Anyway, I need to find the radius here in order... Oh. I need to find the radius here in order to find the area, right? So 50, let me do that again. 2 pi r equals 50. I'm going to divide both sides by 2 pi here. And I'm going to get r equals 25 over... Oh, this thing just crashed on me right at the end here. Come on. 25 over pi. 50 over 2 is 25. The pi stays on the bottom. So 25 over pi miles. All right, the area of this thing, I'll call it, area. Area is pi r squared, so pi times 25 over pi squared. It's kind of weird to see that, but what happens is you take 25 and you square it, you take pi and you square it. So I have a pi on top, I have 2 pi's multiplied on bottom, so pi cancels out here with that pi, and you're left with an area of 625 over pi square miles there. All right, so that's your end area of this whole thingamajig. So when we do population over land area, I'm going to take 50 and divide it by 625 over pi, and I'll get density. So density equals 50 wolves over 625 over pi square miles. So we'll figure out how many wolves per square mile with that. So I'll go to the calculator one last time. Here's the last question, as we're hitting an hour, pretty much exactly. See if I can do this. 50 divided by 625 over pi. And again, put that in the parentheses, because you want to make sure that's all, decimal stuff there. 0.25. So, yeah, I'll just do, those are 0.25. 0.25 wolves per square mile, if I go back there. 0.25 wolves per square mile about. And, although it's not an exact answer, what that means is there is about 1 wolf every 4 square miles, if that makes sense. 1 over 4 is 0.25. About every 4 square miles, you're going to encounter a wolf, right? That's the density, right? That's the idea of that. That's the population. I'll give you this one right here, though. If you want that 1. Was that other number 1? Yeah, 1. If you want that 1, I can throw in the 1. But, it's about a fourth. One wolf every 4 square miles. All right, so that's all the stuff right there. Now listen, that was pretty challenging, right? That was a lot to do, but I hope that a lot of that made sense there. The ratio stuff, if it's new to you, I understand you can square it and cube it and stuff like that. But that ought to do it for this one, guys. If you do have more questions, please leave questions in the comment section down below. Thank you. Take care.